Hello everybody. We now study common logarithms. So common logarithms are the logarithmic functions to base 10. So to define common logarithm, the logarithm with base 10 is called the common logarithm. Is called a common logarithm, and it is denoted by omitting the base. That is, you do not write the base for this, so you just write log x. So this is nothing but log x to the base 10. So from the definition of logarithms, we know that log 10 is that number, the exponent, so that would be 1, correct, for which 10 has to be raised to get 10, so that would be 1. And what is log 100? It is which is the power for which 10 has to be raised to get 100, it is 2. So log 100 is 2. So but how do we find this? These are very easy to find using just the definition. But if you are given log 50, so how do you find this? So we find the exponent y such that 10 power y is equal to 50, right? So clearly 1 is too small and 2 is too large, because 50 lies in between 10 and 100. So the log 50 must lie in between 1 and 2. So therefore we can conclude that 1 is less than log 50 and log 50 is less than 2, correct? And to get a better approximation, we find a power of 10 closer to 50. So we use scientific calculators where we have this log key. You can see it in the scientific calculator. So we can enter the values, and the calculator directly gives you the result. Okay, so we can evaluate certain common logarithms using the calculator, and also we can sketch the graph. And let me do a problem which is a real world problem for you, so that you will clearly see how do we apply logarithm, that is the common logarithm. This is problem number 98 in your book, which says a certain strain of bacteria divides every 3 hours. So it divides every 3 hours. So if you have an X strain of bacteria, for every 3 hours it becomes X, it is divided, so it becomes X by 2. Okay, if a colony is started with 50 bacteria, so starting number of bacteria is 50. Okay, then the time T, this T is in hours, required for the colony to grow to n bacteria, so is given by T is equal to 3 log of n divided by 50 divided by log 2. Okay, find the time required for the colony to grow to a million bacteria. So 1 million, to grow for 1 million bacteria, we have to find what is our time T. Okay, so how do we do that? We solve this for n is equal to 1 million. So T is equal to 3 log 1 million, okay, divided by 50 divided by, okay, so divided by log 2. So that would give us 3 if you use a calculator. So log of 10 million divided by 50 would give us, 1 million divided by 50 would give us 4.3 times 4.3010, and so on. You still have more numbers, so I just approximated to this. and log 2 is log 2 is 0.3010. Okay, so of 3 times 4.3010 divided by 0.3010 would give us, I'm sorry, 4 times, I am doing something wrong in my calculator here. 3010 times 3 divided by 0.3010. It is 42.86 hours approximately 42.86 hours. So 86 hours in the sense 0.86 in the sense you have to convert, you can convert that to minutes or seconds as well. So this would be the answer. So for the bacteria to grow for 1 million in number, to grow in 1 million in number, so you need this much time, that is 42.86 hours. So this is how you evaluate the common logarithm. So coming to natural logarithms. So natural logarithms are nothing but inverse functions of natural exponential functions. So to define natural logarithms, we get the definition is the logarithm with base e is called the natural logarithm. The natural logarithm and is denoted by ln x. So you need not write the base here. So this is nothing but log e to the base x. So you have this key even in the book also, and all the properties of natural logarithmic logarithms or all the properties of the logarithms will apply even for natural logarithms also. So because ln of x is nothing, if it is defined to be y, that is if and only if e power y is equal to x. So based on the definition of the logarithmic function, so all the properties do apply for natural logarithmic functions. So the properties were, first one, ln of 1 is 0, second, ln of e is 1, and third, ln of e power x is x itself, 4, e to the power of ln x is x itself. So these properties you can relate it to the properties that we defined in the section 4.3 part 1 video. So these are similar, but the only thing is we have considered natural log function here. Okay, so let us solve some evaluation, like let us evaluate certain natural logarithmic functions. For example, if I have to evaluate, say, ln of 1 over e square. So this is nothing but ln of e to the power of minus 2, right? So if you apply property number 3 here, so you can see that you have ln e power x will be x itself. Therefore you have the answer to be equal to -2 using the properties of the natural logarithm that we defined right now. Let me do an exercise problem for you. Say problem number 48. Okay, problem number 48 says that use a calculator to evaluate the expression. Okay, let me use a calculator. So you just have ln key on the calculator also. So ln of 27, if I enter it, I will get it to be equal to 3.9 2958 approximately, or 59. Okay, so okay, they asked me to evaluate the expression up to 4 decimal places, so I will approximate it to 9. Okay, and by using the definition, so I don't have any other evaluations in the exercise, I guess, which uses properties. So I will do an example itself for you. So example was ln e power 8. So this example 9. Okay, ln e power 8. So e power 8 is again you have to apply property number 3, which says that ln e power x is x itself. So this would be 8, applying the property number 3. So if you have ln 5, so ln 5 is nothing but a constant. So now you have to use a calculator for this. So just enter, you have ln key. ln 5 will be approximately 1.6095 or 4. Okay, so now to find the domain of a logarithmic function. So if you are asked to find domain of f of x is equal to ln of 4 minus x square. So as any logarithmic function, ln x is defined for only x being greater than 0. So therefore, the domain of f will definitely be a set of all x such that 4 minus x square will be greater than 0. So that is nothing but set of all x such that x square is less than 4. Correct? So that is nothing but x such that absolute value of x is less than 2. So what do you mean by absolute value of x less than 2? That means x lies in between negative 2 and positive 2. Therefore the domain is nothing but open interval negative 2 to 2. So you can also draw the graph using the values, like establish the table of values and draw the graph, and also find the asymptotes accordingly. So coming to your quiz 4.3.3, sorry, 3, right? Yeah, 4.3.3. Do problem number 98. 98 I did it. So problem number 100. So problem number 100, and I think that is enough for you. Problem number 100. Okay. So this would be your quiz 4.3.3. Problem number 100. Okay, this is the end of the chapter 4.3. That is section 4.3. In the next section, we will learn about some laws of logarithms, so that are used like forever in math, just like the formulas, the special product formulas and the special factorization formulas. These formulas you will use it forever, like as you go to the higher classes. So it is necessary to learn all these laws by heart, and it is necessary to learn, like, to see these laws being applied, and how can you apply, even if it is not like clearly visible in the initial stages in the question, but you should see like there is always a possibility of applying these laws. So we will learn all this and problems related to that in the for further videos.